All right. In this video, I just want to make sure you understand what I'm looking for regarding your work on the test for 5, 6, and 7, 5, 5.6, 5.7. Primarily, I want to show you the examples of the work you should show. Okay. Just worried you may not understand what I'm really looking for. Okay, so several of the problems deal with graphing, and you'll be using a tool on the computer to graph where you might just be putting in the phase shift or the amplitude or the vertical shift. But I asked you to show me the progression of graphs, or at least show me the points that you could plot, the 5 key points that you could plot, okay? So I don't want you just choosing the multiple choice answer and not showing me any real work there, or just graphing what the finished product looks like. I really want to see kind of how you could figure this out on your own. So I want you to do it similar to what we've been doing in class. So we talked about if it's cosine, sine, secant, or cosecant, we're going to set up an inequality using whatever you see as the input to the trig function. If it's sine, cosine, secant, or cosecant, the inequality we're going to use is looking at between 0 and 2 pi. The old period would be 2 pi. You set up the inequality from 0 to 2 pi. Okay? All right, now we're going to use this to determine the phase shift and the amplitude, and it's going to help us to get the 5 key points figured out. Okay, let's see, I better leave a little more room. Help us to get the 5 key points that we've been talking about, okay? All right, so I'm going to work through that inequality. So I'm going to subtract pi over 3 from both sides. When you're dealing with these problems where you have pi but also fractions, okay, remember you can use your calculator and just do 2 minus a third if you need to on your calculator. Okay, you don't have to be able to do it in your head. But this would be 6/3 minus 1/3, which would be 5/3 pi. Okay, so if you can do it in your head, that's fine. But you can just enter that on your calculator. Just leave the pi off and put it back in afterwards. All right, then at this point, we need to take half of everything. Divide by 2 or take half of everything. So if I divide this by 2 or multiply by a half, I'd get negative pi over 6. This would be 5 pi over 6 when I take half of that, and this would be just x. Okay, so what all that does is it helps me to see what a nice convenient set of 5 key points would be to find. That'll be the first one. And then I'm going to use 5 pi over 6 for the last one. So we've been working on something in class. What we're trying to do then is figure out what would be the 5 key points that would correspond in a way to what we would have used if we hadn't transformed anything, which would be these 5 points going around here, okay? And so what you do is you take the midpoint of these two, take halfway in between these two. So you add them, and then divide by 2. And again, you can do this on your calculator if you need to. This is negative 1/6 plus 5/6, which would be 4/6 pi. We're going to divide by 2, which is the same as multiplying by a half. You can do all of this kind of thing on your calculator. Just leave the pi out and put it back in at the end. And see how that would be 4 pi over 12. And when that simplifies, that's going to wind up being just pi over 3. Also, depending upon what the values are, you can sometimes see it if you're looking at a sheet of graph paper, or if you have this thing, or if you're looking at the unit circle and you're trying to think about what would be halfway in between those two. Okay. All right. So now let me do this next one in red. So if I needed this spot, okay, it's halfway in between these two. So I'm going to do the same thing. I'm going to take I'm going to take the negative pi over 6 plus the pi over 3 and divide by 2. That's getting the midpoint of those two. So see, that would be negative 1/6 plus 2/6, which would be positive 1/6 pi. When I take half of that or divide by 2, that'll be pi over 12. Okay. So this was negative 1/6 plus 2 pi over 6, which would give me positive 1 pi over 6. But when I take half of that, I'd be at pi over 12. So this is pi over 12. Okay. All right. And then I need to get halfway between these two. So that's pi over 3 plus 5 pi over 6. And then I've got to work that out. So that's 2 pi over 6. See, that would be 2 pi over 6 plus 5 pi over 6, which would be 7 pi over 6, and then take half of that, which would be 7 pi over 12. So this would be 7 pi over 12. Okay, so your calculator can do all of that. You can do 1/3 plus 5/6 on your calculator, get that. And when you get the answer to that right there, you can just divide that by 2, and it will give you 7/12. Okay? All right, so I don't need to see this work right here, but I just like for you to show me those 5 key points. Now, let me clean this up a little bit before we go on to the next part. Now, what happens with these, the reason these work so well, we found, and like I said, we've been working on this quite a bit. Hopefully, you've been looking at my videos. There's a lot, I know, posted. So I just wanted to do a nice, concise one that showed you what kind of work I'm expecting. Okay, so what happens then is if you were to plug those in and you were to take twice negative pi over 6, okay, that'll be negative pi over 3. And when you add pi over 3 to it, you'd get 0. If you do twice pi over 12, you'll get pi over 6 plus 2 pi over 6 would be 3 pi over 6. This becomes pi over 2. See how that's 0? That's pi over 2. The third one, if I plugged it in, I'd get 2 pi over 3 plus pi over 3 gets me 3 pi over 3, which is pi. 7 pi over 12, that becomes 2 times 7 pi over 12. 2 times 7 pi over 12 becomes 7 pi over 6 plus 2 pi over 6. Okay, that's going to wind up being, so 7 pi over 6 plus pi over 3, which is 2 pi over 6. That's 9 pi over 6. That becomes 3/2 pi. See how that transforms into those very nice 5 key spots where we know what the values would be all the way around. And then, like you might guess, if I put in 5 pi over 6, I'm going to have 2 times that, so that'll be 5 pi over 3 plus 1 pi over 3 gives me 6 pi over 3, and I'm back at 2 pi, okay? All right, so now we were doing cosine of that, I think. Is that what I was doing? Yeah. So we were graphing the cosine of that. But because of the values we picked over here for our input, we really are doing the cosine of 0, which we know because we know these quadrantal angles and what those ordered pairs turn out to be. So the cosine of 0 is 1. Pi over 2, the cosine 0. Cosine of pi is -1. 3 pi over 2, the cosine is 0. And 2 pi, the cosine is 1 again. Okay? All right, so if you think about just that part of it and you do the graph, that would be helpful. Okay? So I'm gonna think about the graph of just that. So let's go ahead and get a coordinate plane. You can sometimes do well just using, typical coordinate plane graph, trigonometric graph paper like the one I provided. This one has kind of a strange beginning and ending point, so you might have to just kind of subdivide things yourself. All right, so I'm going to kind of spread my pi out to about here, maybe even a little bigger, since everything happens in such a short period of time. So pi, maybe make it about like that. Okay, so halfway, okay, is not what I'm particularly interested in, but I like to see that halfway point. So do you see how I have 6s and 1/3 and 1/12? So it's like I need to get that pi region broken into 6ths and 12ths. So I'm going to cut it in half and then cut each of those into 3 equal pieces. Then can you see how this would be pi over 6 right here? 2 pi over 6, which would be pi over 3, 3 pi over 6, which would be pi over 2, 4 pi over 6, which would be 2 pi over 3, 5 pi over 6, and then this would be 6 pi over 6. And then I'm going to come over here and put a little bit in the negative direction. Okay, since I have to go back to negative pi over 6. And then pi over 12, wouldn't the 12ths be halfway in between each of these? Okay, so you might want to think about those 12ths, where they're located, because this one's important. That's pi over 12. And the other one is 7 pi over 12. So see, this is 1 pi over 12, 2 pi, 3 pi over 12, 4 pi over 12, 5 pi, 6 pi. Right here is 7 pi over 12. Okay, so let me, in black, show you the location of the x coordinates of the 5 key points. Right, so we need the negative pi over 6, pi over 12, pi over 3, 7 pi over 12, and then the 5 pi over 6. Okay, so let me make sure I labeled the right one. So negative pi over 6, pi over 12 is that red one, pi over 3, 7 pi over 12, and then 5 pi over 6. See how they're all equally spaced? And as you go around the unit circle, we got the outputs for those. So let me put the marks on here. Okay, I'm not graphing the finished product yet. I'm just working on getting these graphed. So negative pi over 6 is at 1, then 0, then negative 1, then back to 0, and then positive 1. And that's where we see that typical look for a cosine graph. Okay. All right, now just a couple things. This part right here, this work we did, move this down a little bit. This work we did right here helps us to get the phase shift and the new period, okay? So this right here, that's our phase shift. It's negative pi over 6, okay? It comes from the B and the C, okay? All right, but I like you to solve that inequality. So that's your phase shift. All right, now for the period, that's whatever this is, okay? The distance from, let me write it down here. The period is the distance from the beginning to the end. So you can just subtract 5 pi over 6 minus negative pi over 6. Take the end minus the beginning. This just happened to have a negative on that. See how that would be 6 pi over 6? So your new period is pi. Your phase shift is negative pi over 6. Okay? So that 2x plus pi over 3 thing, let's move it down a minute. Let me squish it a little bit so we can see that. Okay, that was this input area right here. So that's the B and the C. Okay. Okay. So remember how we had the general thing looking like that. So the B and the C affect the period and the phase shift. Now, an alternative, easy way to do period, the period does come from the B value. You take your old period and you divide by B. The old period divided by 2 would give you a pi as well. Okay. And for the phase shift, you can do the phase shift, but you have to be kind of careful, especially when they give you a plus to start with. Okay. So do you see how the C value is really on this one a negative pi over 3? All right, so your phase shift is C divided by B, but the C you might not identify correctly. It's really negative pi over 3. So it's negative pi over 3 divided by 2. Both of those affect the phase shift, okay? And so that would be negative pi over 6. So you can do that if you want, but there's a lot of room for making errors when you do that. Plus, if you'll do it the way I've been teaching you, then your 5 key points kind of come out of solving that inequality. Okay. All right, now we're not finished with the whole question. The B and the C were inside with the X prior to applying the function. So B and C affect things in the horizontal direction. The 2 is being multiplied by the x, so that impacts things horizontally as a stretching or a shrinking because of the multiplication there. The pi over 3, that plus that you see, means that you're going to affect things horizontally, but it's going to be a shift left or right. And it's not just the C, it's the C together with the B that does that, but it does just move it. So, you don't start at 1 on the y-axis like you used to. You had to shift it some, okay? All right, so you can do your phase shift. You can do it using the formulas, but you have to be careful, especially when there's a plus. Or you can just do the phase shift by working out that inequality, and then that's the new starting point, okay? Right there. And then for the period, you can use the formula that says take the old period and divide by B, or you can just subtract take the end point minus the beginning point. All right, now what we're going to do from here is we're going to wind up looking at the A value and the D value. Those are a little easier to handle, okay? We know that the A affects the amplitude. So the amplitude is 2. And really, what's going to happen, let me see if I can move this. Let me see if I can grab it and move it over a little bit because I need a little more room there. So let me see if it'll let me pull it over. No, let me try again. Okay. And so let me see, copy it, and then let me put it way over here. Good. Okay, now can I move that? Right, hold on. Let me delete that one. Okay. Now I messed it up. Okay, let me just trash that. Oh. See if I can get undone a little bit. Okay, there we go. All right, thanks for your patience. All right, I'm going to try one more time, though, because I really want that moved over. I want to add some columns. Okay, so let me see if I can Control C, move it way over here. Way down there. Okay, I'm about to give up. I'm just going to try one more time. See if it'll let me select it. Okay, so let me move that over. And I'm just going to delete it. Okay. All right, let me just undo that. I'm not going to try to move it. I thought it would be an easy cut it and pull it over, but I can't grab it for some reason. Okay, so what I was trying to move it for is what I really want to do is I want to continue that chart that I had right here. Okay, so if I continued this chart a little bit further and threw a number, man, I don't want to start my video over, so bear with me. Okay. All right, so what I want to do is throw a number right here in front of that cosine. I want to throw the -2 in there and get you to think about it. So let me just continue. Imagine this to be those additional columns. I'm just going to do them over here. So now we're at this, and I'm going to throw a 2 in front of that cosine. 2x plus pi over 3, okay? So just adding another column in there, continuing where we were. And if I did that, see how that would just be 2 times everything? Okay. So I could graph that and it would just stretch every point so that it was 2 times as far away from the x-axis. Now this particular one had a negative in front of it. So that meant it was going to wind up also flipping everything across the x-axis. I think it works well to go ahead and do both of those at the same time. So I don't think that affects anything if you want to do both of those at the same time. All right, so then what I'm going to do is I'm going to go back to that negative pi over 6, and instead of being at 1, I'm going to have gone up to 2 and then flipped it across the x-axis. Okay, when I multiply this by negative 2, it stays where it was. Here I was at negative 1. When I multiplied by negative 2, by 2 would just move it, stretch it down here, but then I flipped it over, and it's now at 2. This point that was at 0 is going to stay at 0, and this point that got stretched to 2 then got flipped across the x-axis. So that same picture is being stretched and flipped across the x-axis. So that's what I'm doing. This I'm doing in blue, including the negative. Okay, so that's this guy right here. 2x plus pi over 3, okay? All right, and then the last thing we're going to do is take care of that plus 1. I'm going to do that in black. That's not too bad. That's just every single point shifting. Since it's positive 1, that's the vertical stretch of positive 1. So that means not stretch. I said it wrong. Vertical shift. Not a stretch. The amplitude is a stretch. Vertical shift of plus 1. So every point gets moved up 1. So let me go back. So I'm going to move that one up 1. This one goes up 1. This one goes up 1. This one moves up 1. Actually, red would have been better. Let me do it in red. This point is here. Okay. This point is here. This point is now there. This point is up at 1. This point is here. Okay. And then I'm trying to do that same cosine look. Okay. And so that would be my final answer. All right. So what I want is for you to show a progression of graphs, or at least this table of values that kind of shows me that you thought through the process and that you didn't just kind of randomly pick your graph or use a graphing calculator and then look at the end result. So I could now take my previous column and add 1 to everything. And if I did, that would show me where all these points wound up. Why this one's at negative 1, this one's at 1, this one's at 3, this one's at 1, and this one's now at negative 1. Okay? And then, of course, these could continue once I get it in both directions. So I'm expecting quite a bit. I don't want to just see a finished graph. I want to see maybe the table of values showing the progression of the graphs with these 5 key points right here, okay, being figured out. Okay, it's still good to talk about amplitude, vertical shift, phase shift, and period, and you will need that in order to use the graphing tool that's in my math lab. So those should take some time. Use the trig graph paper or draw a graph by hand. Either way is okay. Just let me see that inequality getting solved and all this kind of work. All right, if that had been secant, you would have done all that work and just drawn in the asymptotes and showed where the u's that are in the graph would go. Okay. All right, now let me move to a different type of problem. So when you get to those problems, okay, there's some in there that ask you to use a graph. This is my second example. Okay, use a graph to solve the equation, the given equation, and it tells you to for the interval from negative 2 pi to 2 pi. Okay. All right, so let's say they gave you this equation. They wanted you to solve it by graphing. Okay. What they're expecting you to do is to get the negative 2 out of the way by dividing by it. That gets you to here. Okay. All right, then you're supposed to be drawing a graph. Okay, so you're going to really show me a graph and the unit circle and how you figured it out. Okay, so you're going to be thinking about how the 5 key points that you'd be looking at for your sine graph would be those 5 key points around the unit circle. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. And see, it's just x, so you didn't have to do all that solving of the inequality. So then you know sine x, what it looks like. as you go around there, right? So it starts at 0, goes to 1, then it's back to 0, then it's down here at -1, and then it's back to 0. Okay, so that's what it is you got to graph. So you're going to graph 0, 0. Let me go ahead and here's pi, here's 2 pi. So it's going to go up to 1, back to 0, down to -1, back to 0. Sine is the one that starts at the origin. Cosine's the basic one that starts up. Okay. Now, this did say find all the solutions from -2 pi to 2 pi, so it wouldn't hurt to go ahead and extend that so you can think about it. All right, so that's kind of what it should look like. Now, that negative square root of 3 over 2, the decimal for that would be helpful just for me to get the picture on here. So that's negative square root of 3. So let me get my square root of 3 divided by 2. So that's around, so negative square root of 3 over 2 is around negative 0.866, negative 0.9. So if you think about what we just graphed in blue was y equals sine x. And I want you to think about the right side, negative square root of 3 over 2, graphing y equals negative square root of 3 over 2 would be graphing this line that would be down here, down negative 0.866. So when you look at that picture, can you see that that's going to wind up having several solutions? You should wind up with 4 of them. Now, you're not going to be able to draw a good enough graph to see it. This one right here would also be 1 if I wasn't bounded by that interval. So there's a whole bunch more, but within negative 2 pi to 2 pi, I'm going to have 1, 2, 3, 4. Okay, so this is the graph I need to see. I need to see the graph. And then you can reason it out thinking about that unit circle. So go to your unit circle. And you notice on your unit circle that your sine value is going to be negative square root of 3 over 2 when you're like right here. And also you should have seen one over here. So, on the unit circle, look for where you see ordered pairs that have square root of 3 over 2 negative on the sine, on the y coordinate, because that would be the sine. Okay, so do you see how it's related to the pi over 3s? Okay, because like the pi over 3 here has the square root of 3 over 2, positive square root of 3 over 2, but you need it to be negative, so that would be here. All right, and you're doing that in this problem, you're doing it from negative 2 over pi to 2 pi, so you do want to think about rotating in the counterclockwise manner. So it's not here, okay? It's when you get to there. So that's going to be at 1 pi over 3, 2 pi, 3 pi over 3. This should have been 4 pi over 3, and then 5 pi over 3. Okay. All right, and that would be this guy right here. 4 pi over 3 and 5 pi over 3. All right. And then I also want to go in the negative direction. So now I want to think about going from here to here. So see how that would be negative pi over 3, and then this would be negative 2 pi over 3. Okay, so your answer to the question should have been negative 2 pi over 3, negative pi over 3, 4 pi over 3, and 5 pi over 3. And then those of you that were here last class know that we are going to do this analytically without drawing this graph right here. But I really want to see the graph. I want to see where you think the solutions are, and then you go to the unit circle to help you with that. Okay? All right, so that's what I'm expecting on the ones. There's, I think, 2 of them that ask you to use a graph to solve the equation. All right, and then the other type are the ones involving section 5.7. So there's one that was like find cosine inverse cosine of 5 pi over 4. Okay, and so the intent is not for you to plug this into your calculator. If that's all you do, you're not going to get credit. Okay, So I want you to use a sketch. Don't just plug into your calculator. Okay, so what I want you thinking about is how if you're 5 pi over 4, then that means you're over here, aren't you? This is 5 pi over 4. I don't need to know what the cosine of 5 pi over 4 is. I just need to know that I've got to do the cosine inverse of that. So if I did cosine of 5 pi over 4, then I'm thinking about how that would be related to this x right here. So I have to remember, I'm in this section 5-7 area where I have to remember that cosine inverse is going to report an angle from 0 to pi in that interval, from 0 to pi. This is outside that, okay? So what I need to do is find an angle between 0 and pi that would have the same cosine as this one would. And you see that would be right here? Okay, so I should see that sketch. And then you have to think about, well, what's that one? That's not very well drawn because it's supposed to be pi over 4. So it should be more halfway, really. Okay, so it's like that. And so your job is to tell me what that is. That would be the angle I'm looking for. So see how that would be 3 pi over 4? So your answer to this should be 3 pi over 4. Even though we are composing these two functions and you would think they would undo each other, 5 pi over 4 would not be the answer because cosine inverse gives you something, an angle that's between 0 and pi. And so you have to be sure you're doing that. So notice I don't really want to see that in between idea. Okay, this would be negative square root of 2 over 2. Then you're turning around and you're doing cosine inverse of that. But when you do, you got to be sure you're looking up here and you would get the angle because the cosine is negative. You need the angle in the second quadrant and that would be 3 pi over 4. So you could show me that, but that negative square root of 2 over 2 should be not something you just get on your calculator. You should be reasoning it through for me and just remembering cosine inverse has to be an angle in the first or second quadrants, has to the result has to be an angle in the first or second quadrant, something from 0 to pi. Okay, so that's what I'm looking for. Let me do one more from 5-7 because sometimes they look quite a bit different from that. So say you have one from 5-7 that looks something like this. Say somebody asks you to do cotangent of sine inverse of 8 over 17. Okay. Absolutely not expecting you to use the sine inverse button on your calculator at all. Draw a sketch. I think it even says that in the directions. If not, you do it anyway. Okay, so what you should be thinking there is that this sine inverse of 8 over 17 really means I have the sine of some angle that is equal to 8 over 17. Sine inverse gives me an angle in either the first or the fourth quadrant, but since 8 over 17 is positive, I know I'm going to draw it in the first quadrant. So you do that. This is theta. Sine is opposite over hypotenuse. So you would do that, 8 over 17 like that. You would take a moment then to figure out the unknown part of that. You would use the Pythagorean Theorem. You'd say 8 squared plus the unknown thing squared would equal 17 squared, and you would work that out. So that's 64, that's 289. So x squared, when you subtract 64 from that, you get 225, and that means x would be 15. Okay, so now I found this. I know x is 15 right here. All right, so I don't really ever need to know the angle, and I don't want to know the angle. What I want to know is the cotangent of that angle. So if this is the angle I'm dealing with, and I have all the parts of the triangle listed, I just have to think about how cotangent is adjacent over opposite. Adjacent is 15, opposite is 8, and there's my answer. Or you could have gone through tangent if you prefer. Do tangent first and then flip it. Do you see how you never find theta? This is the sketch that you would do. Okay, so So let me stop this. It got a little longer than I expected. I kind of did a review rather than just showing you the work I'm expecting to see. All right, but let me go ahead and post that.